Yo, what's up, my guys? Welcome back to another video. And today we're gonna be talking about trig derivatives and how to find them and where they come from. So I'll be trying my best to explain these derivatives. And so let's talk about the first function you normally learn from trigonometry, which is sine of x. And if you took pre-calc, you may know that the graph of sine of x may look something like a little wave. Woo, it goes like that, right? So from here, what I can safely assume to you is that since the derivative is just another name for slope, the slope, let's just say sine of x is f of x. Let's just say that the derivative of sine of x is just equal to cosine of x. Reason why that is because let's say we made another graph for cosine of x. Cosine of x starts at 1, and then it goes like this, drops down, goes up, drops down, goes up. You can see that on the original sine function, this is cosine, you can see how the derivative goes up, hits a little horizontal point at 0, goes down, and then goes up again. From here, we can see how that's made possible. We know that when you take the derivative of something, when the slope is increasing, it means that it's positive slope. So that means that we have to look at top of the x-axis to mean that this is positive slope and this is negative slope. From here, since we know sine of x is positive on this axis until it gets to, I think, pi half, we know that cosine of pi half is just equal to 0. And this is exactly what we see here. So from here, we know that this is positive slope until it hits 0, then it's negative slope, just like how this hits it, until this way, and then from this 0, the slope is positive again, which is why the derivative of sine of x is just cosine of x. From here, the derivative of cosine of x is just equal to negative sine of x. When the derivative of negative sine of x is just equal to negative cosine of x. From here, the derivative of negative cosine of x is just equal to sine of x. So what we essentially did is we just went back in a big loop. That's essentially what sine cosine derivative relationship is like. And essentially this graph is just an easy way to visualize that in case you're more of a visual learner. This is just how I like to like it. Obviously, you can always just remember the little pattern. It goes sine, then cosine, then negative sine, negative cosine, then it goes back to sine. So what about the other ones, such as cosecant x, cotangent of x, secant of x, and tangent of x? Let's do tangent of x first. We know tangent of x is just equal to sine of x over cosine of x. To take the derivative of tangent of x, which is equal to sine of x over cosine of x, what we can do from here is just do the quotient rule. And if you saw my other video, you would know that the quotient rule starts with the bottom function times the derivative of the numerator minus the numerator times the derivative of the bottom function all over cosine of x. From here, we get cosine square of x plus sine square of x, cosine x squared, plus sine square of x all over cosine square of x. Since we know trig identity, we know cosine square of x plus sine square of x is just equal to 1 all over cosine square of x, which is just equal to secant square of x. Pretty simple, right? And this is the idea with all the other ones. So since we're talking about secant, let's just do secant right now. Secant of x. We know secant of x is just 1 over cosine of x. From here, we just do quotient rule all over again. Times 0, because the derivative of a constant is always 0. Minus 1 times the derivative of cosine of x, which is just negative sine of x, all over cosine of x. From here, s is 0, so we can just do that. Negative 1 times negative sine of x is just equal to sine of x, all over cosine square of x. We know that cosine square of x is just another way of saying cosine of x times cosine of x. And from here, we can take this sine and this cosine, and we can make that tangent of x, to simplify, times 1 over cosine of x, which is just equal tangent of x times secant x. And that's the derivative of secant x. And essentially, this is just the idea for the whole trig derivatives. Really, just except for sine and cosine, you can derive any other trig derivative just using the quotient rule. And then we can do the same for cotangent of x. Cotangent of x is equal to cosine of x, because it's just the opposite of tangent of x. Cosine of x all over sine of x. We do quotient rule again. From here, we get negative sine square of x minus cosine square of x all over sine square of x. You might be tempted to try to break this apart, but I say no. Factor out negative. Then you get sine square x plus cosine square of x all over sine square of x. Again, since we know trig identities, we can just say that sine square of x plus cosine square of x is just 1 times a negative, which is just negative 1 over sine square of x, which is equal to negative cosecant square of x. And then finally, we're on to our last derivative, which is just cosecant of x, which is equal to 1 over sine of x. We just do quotient rule again. We just do the same thing for here, since we know sine square of x is just sine times sine of x. We can take this cosine, this sine, and we can take the negative, and we can say this is negative cotangent of x times 1 over sine of x, which is just equal to negative cotangent of x cosecant of x. And that's all our derivatives summed up. Let me see if I can remember them from my head, because I just derived most of them. So first off, for sine of x, let me write d dx for all of them. We know the derivative of sine of x is just equal to cosine of x. We know the derivative of cosine of x is just equal to negative sine of x. And then the pattern just continues, which is what you could remember. And from here, we also have our other trig functions. I forgot the last one. Oh yeah, cosecant. So that's essentially all our trig functions. These are just the derivatives of all of them. Obviously, I did the inverse derivatives on the other one, so go look at that as well. But essentially, these are all the derivatives of the trig functions. Not all of them, because obviously you have like a fucking something crazy inside, like this, obviously. But again, this is just a basic formula for how to find derivatives of trig functions. I think I'm right. I don't know. I may not have this from memory. I believe this is right though. So essentially, this is just a way to derive, your trig functions either by visualization or just by using quotient rule. So essentially, that's the video. Thank you for watching. And if you have any questions or if I made a mistake somewhere, leave something down in the comments. I'll be happy to respond. Thank you for watching. This has been Trig Derivatives. And goodbye.